सर्वेपि सुखिनः सन्तु सर्वे सन्तु निरामयः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःख भाग् भवेत्. Hello friends, today we'll see this numerical. Two bodies weighing 300 Newton and 450 Newton are hung to the ends of a rope passing over a ideal pulley. That means ideal pulley is having frictionless pulley. With what acceleration the heavier body comes down, this is the heavier body, and what is the tension into the string. So to solve the numerical, first of all we'll see the FBD. Okay, so what is the FBD? We'll see FBD for block 450. Just by observation, since the 450 Newton block is heavier, that's why the moment for the block will as like this, is it? So the self weight of the body acting vertically downward 450 Newton, and there is a tension into the string, is it? Suppose I cut down this particular string, what will happen? This block will fall down. That means there is a presence of tension, and tension is always away from particular point. That's why tension is upward. And since the movement, this is movement, is it? This is the movement of the block, and the inertia force you are applying opposite to that of acceleration. That's why inertia force is above. This is the FBD of this particular 450 Newton block. Then we'll draw FBD for block number 300. For block 300, since suppose I cut down this particular string, then what will happen? This particular 300 Newton block will fall down. That means one of the tension is present into the string, and tension is always away from this particular point. Self weight of the body is acting vertically downward always, and the movement of the block is as like this, upside. That's why the inertia force is towards downside. Inertia force is given by product of M into A. Okay, now we'll apply equilibrium conditions for individual blocks. So apply equilibrium conditions. Summation f of y is equal to 0. Since tension going upward plus T and 450 coming downward, that's why minus 450. Inertia force is going upward, so plus ma is equal to 0. Therefore T minus 450, mi replace mass by W by G. So this is W1 divided by G into acceleration is equal to 0. So weight for this particular block is 250. Therefore T minus 450 plus 450 divided by 9.81 into acceleration is given into the numerical. What is that value? No, we have to calculate acceleration. We have to calculate values of for acceleration and tension into the string. See it as equation number 1. Okay, then apply equilibrium condition for block number 2. Now apply equilibrium condition for block 2, block 2. Okay, this is our FBD for block 2. So summation f of y is equal to 0. Summation f of y is equal to 0. Since T is going upward, consider it as plus. 300 is going downward, minus, and the inertia force is coming downward. That's why minus ma is equal to 0. May I replace mass by W by G? Therefore T minus 300 minus weight of the block is 300 divided by 9.81 into acceleration to calculate is equal to 0. See it as equation number 2. Now observe equation number 1 and 2. The equation 1 is terms of T and A, and equation 2 is also in terms of T and A. So what can be done? Suppose equation number 1 minus equation number 2 we did, then T get cancels and you can calculate value for acceleration. Let equation number 1 minus equation 2. Therefore this T term get cancelled. Then tell me value for A. What is the value for acceleration? 1.96 meter per second square. The unit for acceleration is meter per second square. Now put this value in one of the equation and calculate value for tension. Now put acceleration is equal to 1.96 in equation 1. Therefore, tell me value for T. 360 Newton. Okay. As such, we have calculated values for acceleration and tension. Thank you.